Welcome to part 2 of 4.3. We're going to look at slope a little bit more. So, just moving into this first one here, we want to graph the points and find the slope of the line containing these points. The first one we have 2, -4. So we go 2 here, then we go 1, 2, 3, 4. So that's the point 2, -4. And now it looks more like a 4. And we have -3 too. So 1, 2, 3, 1, 2. We're looking at that right there. So -3, 2. So really, if we think about the line that goes through them, it looks about like that, okay? Now we can think about this in two contexts. One thing, if we look at this, because as we read from left to right, the slope is decreasing and going down. And then we can also think about, like this, like what is the rise, or the negative rise, and what is the run? Well, if we go from y equaling 2 to -4, to go from 2 to -4, we've gone down 6. So if we think about this as rise over run, -6. Then the run, if we start at -3, takes us 3 to get back to here, and then we go 2 more, so 5. So the slope of that line that contains these points right there is that. Now we can also, let me do this real quickly, we can also use the slope formula on this. Now recall that the slope formula is m equals rise y2 minus y1 all over x2 minus x1. Now I'm going to label these just x1, y1 and x2, y2, just to label these points. Now when I plug these in, our y2 is 2, so we have 2 minus our y1 is -4. So plugging that in there, over our x2, which here is -3, minus our x1, which is 2. When we do this, our numerator, this 2 minus -4, is really 2 plus 4, which is 6. -3 minus 2 is -5, and you'll notice -6/5 is the same as -6/5, and we're good with that. Okay? So two different ways. Generally, like, we could do this some of the times. This formula right there works all the time, and we are going to be using that as we move it into to the future. So looking at this next one, plotting these points, -3, 5, 1, 2, 3, 1, 2, 3, 4, 5. So that's, we can say that's -3, 5, and then 4, 1, 2, 3, 1, 2, 3, 4, -3, 1, 2, 3. We're down here for -3. Now, just visualizing this sort of thing right there, we can see that the slope's going to be negative, okay, because we're going down again. And if we think about it as rise over run, we can think about what that's going to be. Now here, rise, we're going down, run, we're going over. So we think about how far have we gone down. Well, to get from here down to here, we've gone down 5. We need to go down another 3. So all told, we've gone down 8, so -8 is the rise. Now with the run, we're starting here at -3. It takes us 3 to go back here, and then 4 to get over there. 3 and 4 is 7, so excuse me, -8/7. We can think about that. Now, if we're using the slope formula, m equals y2 minus y1 all over x2 minus x1, we can label these points. We can call this right here x1, y1, x2, y2. Plugging these things in, y2 is -3, so -3 minus y1 is 5. Then our x2, plugging that in, that is 4, minus our x1, -3. And once again, notice, -3 minus 5 is -8. Negative to positive, so 7, -8/7, same as -8/7. So that we're looking good on both of those right there. Now, these ones down here, we specifically want to use the slope formula to find these right here. Now, find the slope of the line containing these points. So I always put m equals y2 minus y1 all over x2 minus x1, and I write the formula every time because that writing the formula gives us repetition, and that really ingrains things in our memory. So I'll do that. I also label these points x1, y1, x2, y2, so when I plug these in, I don't get confused as to what's going on. So notice y2 minus y1, we have 2, which is our y2, minus -1, which is our y1, all over our x2, which is 5/3, minus our x1, which is 2/3. Now, numerator, 2 minus negative 1 is really 2 plus 1, which I'm going to write as 3, but because we have fractions in the denominator, I'll write that as a 3 over 1. In the denominator, good news. We have fractions, but we have a common denominator. So, 5 thirds minus 2 thirds, well, 5 minus 2 is 3. So we get 3 thirds. So we can think of 3 thirds as 1, so we have 3 over 1, which is nothing more than 3. So the slope of the line containing these points right there is, in fact, 3. Okay? Or we can say that's 3 over 1 if we want to think about it in the context of rise over run. Now this next one over here, once again, our m equals y2 minus y1 all over x2 minus x1. So this is our x1, our y1. This is our x2 and our y2. So we're just plugging these in. We have 3/11 minus 3/11, so our y2 3/11 minus our y1 3/11 all over our x2 5/4 minus negative 1/2. Now good news, in the numerator, 3/11 minus 3/11 is 0, and then 0 over anything, it doesn't really matter what this is, 0 over any number that is 0. So the slope is 0, so really that means we're not going to rise at all, we have run, which means if we're not rising and just running, that's going to give us a horizontal line. So a slope of 0 is the slope of a horizontal line. Now, a lot of things in life, we use slope to actually measure things, and the pitch of the roof is one of these. When we actually talk about the pitch of a roof, if we have a 512 roof, if it says right here, that means that for every 5 inches we go down, we're going to go 12 inches over, so the steepness of a roof really has to do with pitch, and if you've ever re-roofed your house, you don't want that steep of a pitch. So, calculate the pitch of the roof using the diagram. Now here's the deal. This is a 512. Right here, they're saying that this distance that they've gone down is 3, so the rise being 3, when the run is 12. So the rise here being 3 over the run 12, thinking about slope as rise over run, and we can simplify that a little bit to a pitch of 1 over 4. So essentially for every 1 inch we go down, we go 4 inches over. So if we went down 2 inches, we go over 8 inches. If we go down 3 inches, we go over 12, and that's what we're saying right there. So, yeah, hopefully that made sense, and we'll see you next time.